Okay. So have you all gone through the lectures of the like, week 5 period? Yes, no, maybe nothing. Have you all gone through the lectures or not? Can you hear me? I must be previous class if you can please say. Okay, so some of you are saying that they've already gone through the content. Okay, so in the last lecture we have just went through from starting first week to the fourth week. From now onwards, we'll start with the permutation. I'll just give you an idea about the permutation and combination, and then we'll try to solve some of the problems that may help you in the exam. Uh, like I'll start. I'll just share my screen. So anyone will any in between, if you have any doubt, you can just unmute yourself. You can ask without whatever doubt that you have. Sorry. Can you see my screen? Is it visible to you?
Yeah. Yep.
Yes.
Okay. So, we'll start with week 5. Where mostly we are just going through the principle of counting, and this is pretty simple. I'll just give you an idea in 2 minutes and then we'll solve some problem. So in this week we are just going through the basic principle of counting. And this we have one is addition, one is the multiplication rule. Okay. See, wherever you have that word or, right? Or I mean to say that if you have been given action A, and that can occur in N1 different ways, and if you have an action B or event, you can say event A and event B, and both of them are occurring in N1 and N2 ways. And if you have been asked to calculate the total number of ways such that either A or B will occur. So wherever you have that word or, you can use this addition rule. Okay, let's for example, like if you have been, so there was an example in the lecture itself. I'm just using the same example. So you have some gift card and you have to buy uh, like a combination or maybe a dress, and you have been given an option of 4 t-shirt and 3 pants as there, I guess. So the first event is what, like 4 t-shirt is there and then you have 3 pants, and you have been if you have been asked to buy either a like either of the two, then you can buy it in N1 plus N2 ways, right? 4 plus 3 ways, basically 7 ways. And the other case can be if you have been given, if the action A can occur in N1 different ways. So this is for wherever you have been given and. So here you have N1 ways of event A and then N2 ways of event B, and you have been asked to calculate either of A or B. Then you can directly add it up. So the basic concept, maybe with the examples, it will be much clearer. And N1 ways for again same thing, A, N2 ways for B, and then you have been asked to calculate the number of ways in such a way that A and B are agreed. Okay, A and B. So both are there. Then it will be N1, N2, N2 ways. Correct. So let's solve one problem. This clear, right? This was much easier, and I hope you already know about this. The question is, mm, let me write it down. It's a simple problem. We have been given that there is a basically 13 flight or n number of flight, or maybe let's for example Delhi, this is Bangalore. There are 13 flights from Delhi to Bangalore. Okay, and then you have six flights from Bangalore to Chennai. If someone wants to fly from Delhi to Bangalore and then to Chennai, and how many possible ways can he go, or can he plan to go from Delhi to Chennai? This is simple, right? How will you do that? Which one will you be using? Addition or multiplication?
Multiplication.
Correct. So yeah. So these are simple. And then you have to go through the factorial. Right? So this was simple. And then factorial. I hope you're already aware of that factorial. So n factorial you can write it as n times n minus 1 factorial. Correct? And any factorial, like for example 5 factorial, if you have to calculate the simple 5 into 4 into 3 into 2 into 1. Very simple. Then you should be knowing about so this was just the counting. On the counting, how do you, mostly there won't be any questions that will be asked like that simple. Now we'll deal with the permutation. So in the permutation and combination, whenever you have been given some n different objects and then you have to choose out r different objects and then arrange it. So in the permutation, the arrangement or the order is very important. Okay, that is not yeah. So whenever we have been given, I'll just write it out n different in this thing, objects are given, and r. So this is important. In the permutation, there's only one difference in the permutation and combination. In the combination, you choose out like if you have been given many different objects and you have to choose out some R. So basically, you just choose out. You don't have to worry about how will you order that in the combination. In the permutation, basically you have to arrange those things. Okay, so you have to calculate how many ways you can, after choosing out how many ways you can arrange those things. Okay, so let's for example, if you have been given some three words and then you have to choose out, you have to use all the three words. Okay, ABC has been given to you, and how many ways you can arrange these three words. Okay, so it's like this is also simple. ABC. Now you have three options, so you can just take out ABC, all the three here. Here, if you have chosen out one of the words, then you are left with two words, right? So whatever you have chosen, let's for example, in the first you have chosen A, then you are left with one some B and C, and then in the end you'll be left with some one more, right? So in the first you are left, you have all the three options. In the second you have two options left, and then in the last you have only one option that needs to be arranged, right? So you have basically three factorial ways, correct? So this was like you have been given n different objects, and then you are choosing out all the objects at a time. So you can directly use the factorial uh, thing. But if you have been given some n objects and then you have to choose out r objects, then what? This is also simple, right? So you can just, let's for example here you have been given ABC, and then you have to choose out only two words. Okay, two words you have to choose out and then arrange it. So here also, in the first place, you can just think of that you can just take out a out of this ABC, all the three can come here, right? And then in the second option, you can just take out that if one of them has been already chosen, then you are left with two words. So here also you have six different ways that you can arrange. You can just choose out from ABC, you can just choose out two letters and then arrange it. Right here also you have six ways. But here by mistake, it is same, but it will not be same always, right? Let's for example, you have been given now, I'm giving you ABCD, and now you have to just in the first attempt you have to take all the four words and then arrange it. So then it will be same four factorial, because in the first place you can have ABCD all the four. In the second option, like in the second place, you can have three out of four, and then in the third you can have two, and the final you can have one. So four into three into two into one is four factorial. But if I'm telling you to just choose out two words, then you are just left with, in the first place you can just take out of the four only. You can just take out any of the four, right? But in the second place you can just take out three words, right? So you are left with how many words, like how many different ways that you can arrange those after choosing only two words is 12, right? So now you can see that it has been half. So earlier it was 24, and now it has been half. Okay. So this was just the basic idea about the permutation. Let's solve some problem. Maybe that will clarify your doubt. So the questions can be, yeah, and one more thing. So what I was saying, so here it has been given all the n distinct, okay, n distinct objects from where you have to choose out. But there can be some questions where the objects are not distinct. Let's for example, you have been given some words like statistic, or maybe a simple word like a data. I guess the same example was there in the lectures also. And then you have to take out two words, or maybe all the four words. In the first case, you have to take out and then tell me out of all the number of arrangement you have to tell me. Okay. So how will you do that? Can somebody tell me? If you have this four, all the four objects are not same. You can see that A and A are like both A are same. It's not like A1 and A2. It's both are same. Then how will you? What can be the number of arrangement?
So it will be 4 factorial and A is duplicate, so divided by 2.
Correct. So yeah. So whenever you have, when all the objects from where you have to choose out are not same, then it's like first case you can just do it like, you can just think of as A1 and A2. So if it is A1 and A2, and then you have to do the arrangement, then here four, like all the four can come, and then three, two, one. So basically four factorial. But you can see that A1 and A2 are same, right? A1 and A2 are same. That is basically A. So you are just doubling all your arrangement, right? So you just divide it with two factorial. Okay, so that can be the case if you have, if all the objects from where you are taking out, if you are choosing out, that is not distinct. Okay, here you can see that A is not distinct. A1 and A2. If you are taking A1 and A2, that is distinct, but basically A is not distinct. So you just have to divide with those many values. So let for example you have n objects was there. In out of that n objects, it's you have three different objects, P1, P2, and P3. One second, one second. So I was saying about for the permutation, yeah. So for n distinct object, so you can directly write the formula as NPR, and NPR you can write it as n factorial upon n minus r factorial. This for the first case where you have been given n distinct object, and then you have to choose out different objects from there and then arrange those words, arrange those objects or words, whatever you want to call it. So you can use directly NPR as a formula, or where NPR the formula can be written as n factorial upon n minus r factorial. Okay, this will work like for our case. In the first case, what was the case where we have to use all the three words, right? So or if you have to use all the three words, that is basically npn. Okay, if you have npn, then you are left with n factorial only. In the second case, I said you have to use out of three, you have to choose two, right, and then arrange it. So you can choose it np, like 3p2. That will be what? 3 factorial upon 1 factorial. So same answer you'll be getting. In the third case, whenever we were dealing with four objects. So you have four different objects. In the first case, I choose all the four. So you'll be left with NPN. That is 4PN, 4PR. Yeah, so you'll be left with 4 factorial itself. In the second case, we are dealing with when out of 4, you have to choose out 2, right? So that will be 4P2. So you'll be getting the same answer you do with this formula directly, or you do with the basic approach. You'll be getting the same. Yeah, or you can say the counting or the factorial approach, you'll be getting the same answer. Okay. Now, in the second case, we were dealing with whenever you don't have all the objects as a distinct. You can have some of the repetition values, repetition of the words or of the objects. Okay. So in those cases, what you'll be doing, you'll be just in this the approach will be same. Only you have to divide with all the values which are repeating. Okay. So it can be something like n factorial upon p1 factorial, p2 factorial, p3 factorial, pk factorial, something like that. Okay, if we have repetition of some words, so if some words is getting repeated p1 times, then some words is getting repeated p2 times, some words is getting repeated pk times. Okay, so you can just do it like that. Okay, is there any confusion in this? No, right?
Yes, no.
Okay. Okay, if you have been given a word, this, can you tell me what can be the total number of arrangement?
10 factorial.
10 factorial. Then there is some repetition, right?
That
The
Yeah,
repetition of words.
3
Yeah, so
factorial.
3
3,
factorial
And
for T.
2 factorial.
3 factorial
3.
and 2 factorial.
This is for T, this is for S. And then
One more 3 factorial.
for
Yes,
what?
is
For yes. For
right.
yes and T are 3
Okay,
times, right?
sorry.
Yes, and yeah,
Okay.
3, 3, 2.
And then, yeah, for I you have to. Got it. So this will be the answer, correct?
Yeah.
Yeah. Okay. So this is okay. And one more thing, if you have a repetition is allowed. So if repetition is allowed, for example, you have some word A, B, C, and D. If the repetition is allowed, then what can be the number of ways? So when the repetition was not allowed, what we were doing, we were just taking out in the first place, all the four can come. In the second place, only three can come because you already know that one has already been used. So repetition is not allowed. So you'll be taking 3, 2, 1, something like that. So 4 factorial. But if you have repetition is allowed in the first case, also you can take all the four words. Yeah, yeah. You're asking something?
No, no, no.
Yeah. In the second case, you can take all the four. In the third, also you can take all the four, and the fifth, like in the third, fourth place, also you can take all the four. So you'll be left with what? 4 to the power
Good.
4. Correct? Is it clear? So whenever you have n object and you have to choose out R, okay, from the n distinct object, R you have to choose out and then arrange it, and repetition is allowed. Then what can you do? You can directly write it as n to the power R. Can you please mute yourself, whoever is? Can you please mute? Okay. So what I was saying, whenever you have a reputation, whenever the reputation is allowed, you can directly use it formula. You can see that from our example ABCD, like it work here, it will work always. Whenever reputation is allowed, because you already know that if reputation is allowed, there won't be any reduction in the number. We can use all those objects again and again in all the places, right? So if you have some R places that you have to choose out, fill it. So all the n can come here. Here also all the n objects can come here. So all the places, all the n objects can come. So that's why n to the power r can be the number of arrangements. Okay, this is clear? I hope this is clear. Uh, Let me check. Okay, can you solve this? So this type of problem can come, like for example, just to simplify the, like for example, n plus 1, p2 equals to 4, np1. Can you tell me the value of n? So this type of problem can also can come in the exam. Can you solve this? It's simple. You just have to simplify this and calculate the value of n. The answer will be 3. We already know n plus 1 factorial upon, you can just write it out, n plus 1 minus 2 ka factorial equals to 4 times n factorial upon n minus 1 factorial. Just simplify it, you'll get the value of n equals to 3. Okay. So the next problem that you can solve it is, can you hear me? Are you able to hear me?
Yeah.
Yes, sir.
Okay. Okay. So the next problem is, you have been given that there are 8 people in some committee. So there is a bunch of people. There is a committee where you have 8 persons there. There is some committee. 8 person is there. And out of this 8 person, you have to choose out 2 people. Okay, one for the chairman and the second for the vice chairman. And there is no repetition. So one person can be filled in for the chairman and for the, like for the both the posts, right? There can't be, that can't happen. So in how many ways you can choose out the person?
8 multiplied by 7.
Yeah, that is simple, right? For the chairman post, this is for chairman post, and this is for vice chairman. So all the 8 person are like there for the chairman, and if somebody has occupied the chairman post, then you are left with 7%, right? So this is pretty simple. 8 into 7 days. Okay. So now the next question is, if we have to find the 4-digit number. Okay, this is also simple. You just have to use. Uh, you have to calculate all the 4-digit number that can be formed from 1, 2, 3, 4, 5 if repetition is not allowed. That is like 5T4, correct? Out of this 1, 2, 3, 4, 5. Okay, if you have to just make 4-digit number, you can directly choose out 5P4. If there was a 0, then you'll have to do some combination, like you'll have to use some basic concept. Otherwise, if the 0 has not been given, then you can directly write it as NPR or 5P4 if you have to make a 4-digit number. Okay.
Yes, sir.
Yeah. Okay. So the next concept from the permutation is the round permutation. Okay. If you have been given, if you have to arrange those objects in a circle, then what are the concepts? We'll just deal with that, and then so the concept related to the round permutation. See what happens in the round permutation. So earlier, what we were doing, if you have been given the objects, and then you have to just, whenever we were arranging, we were just arranging in the linear permutation, right? We were just, if you have to, let's for example, you have to arrange ABC. You're just writing it as ABC, okay, and then ACB, something like that, right? You're writing in this way. But whenever you write in the circular permutation, in the round case, If you're writing something like that, A, B, C, and then one example is A, B, is something like B, C, A. So both are same, right? Or different?
Same answer.
Correct? Both are same. So something else has to be done, right? Apart from that linear permutation that we were doing, something else we have to do it in the round permutation. So can somebody tell me how like what should we do in the round permutation?
Generally, if it is n pictorial, round n minus 1 pictorial.
Yeah, so you just have to fix, yeah, you just fix the position of the one object, and then with respect to that object you can just place the other object, right? So if you are just fixing the if you are fixing the place of one object, then you are left with only n minus one object, correct? So n minus one object can be you can just arrange those left n minus one object in the n minus one factorial ways, correct? So you just have to fix one object, and then if you're just fixing one object, you're just left with n minus one objects, right? So the same for n minus one object. How what's the total number of arrangement? It's basically n minus one factorial ways, correct? So this is what you do in the round permutation. But in the round permutation also there can be some cases where you can be said that anti-clockwise or the clockwise. That if you're moving from clockwise and anti-clockwise, both the direction are same. Then what can be the number of ways? So then you have to just divide it with 2, because you already know that whenever you were doing that problem where data problem, right? When you are getting something that is same, right? So here A1 and A2 were same, so you just divide it with 2, because you were just whenever you were making those arrangements, you were earlier you were taking A1 A2, right? Because you were taking A1 A2, that is like totally different. A1 A is based, you were taking the starting A1 and A2 as a different, but in the reality both the A are same. So that's why we're dividing with 2, such that the number of ways should be coming as a correct answer. So in the same way, in the round permutation also, if you have been given that the anti-clockwise and the clockwise are same, so you will have to divide it with 2, because whether you are going from this way or this way, both are same. So if they both are counted as the same arrangement, so you just have to divide it with 2, because you have counted in both the ways. You have counted in this way also, in this way also. You just divide it with 2. So the final answer should be what? N minus 1 factorial upon 2. I hope this is clear. If it's not, then you can just ask me the doubt. Is it clear? So I'll just write it. Maybe that'll. So in the round permutation, you can have two things. So first of all, in the round permutation, you're just fixing. Fixed one place for one of the object. If you're fixing one place for one object, you're left with n minus 1 factorial. So n minus 1 factorial is the number of ways you can arrange an object in a circular way. But in that case also, you can have clockwise equals to anti-clockwise. Okay, or clock not equals to anti-clockwise. If you have been given clockwise not same as anti-clockwise, then your answer is correct, n minus 1 factorial. But if you have been given that the clockwise, if you're coming from this way and that like the other way, clockwise or anti-clockwise, if both are same, then you will have to divide it with 2, because you have counted both the ways. If you have counted, you have to divide it by 2, okay, to get the final number of ways. Is this clear to everyone?
Yeah.
Yes, sir.
Yeah. So what can be the number of, if you have been given how in how many ways four people can sit in a round table? Four people can sit in a round table. If the anti-clockwise and clockwise, like if they're sitting, that means all the four people are different. So clockwise and anti-clockwise are different for this case. What can be the number of ways?
4 minus 1 factorial, which is 3 factorial.
Correct. Yeah, that's correct. Yeah, and if that is given, yeah, that's correct. And for clockwise and anti-clockwise both are same, then you can just divide with 2. So 3 factorial upon 2 would be the correct answer for this case. I guess the permutation is clear. Let's move to the combination. Is there any doubt in permutation, or you want to solve some problem from the permutation?
Sir, that gap as well as that combine one, that outside.
Which one? Which one?
Like suppose, sir, then suppose 6 persons are there, then 2 persons are sitting together, or that kind of problem it is.
Okay, okay. Let me check whether I have. Oh, okay, okay. 1 second. Okay, let's. One question is there. So,
But
so
I
the
know
question is,
like six girls have there, four boys have there,
yeah,
they
yeah,
sit together. That one also. Okay.
yeah, got it, got it. Okay. So the question is, so there's a word Ujjain. Okay, so Ujjain has been given. Okay, you have to form a three-letter word. So how many? I'll just write it out. So how many three-letter word can be formed using the word of this Ujjain? Okay, and the thing that is there is without repetition. So without repetition, and the condition that is given is such that the alphabet I is one of the alphabet in each of the words that is formed. So this is simple, I guess. Yeah. Without repetition, an I should be there in each of the word. Can you solve this? Can you give me the approach? How will you solve this? You have understood the question. You have to just make three-letter word without repetition, and there whether whatever the three-digit letter that you are making, that can be with or without meaning. That is not our concern. It's the only concern is the word that is being used is without repetition, and I is one of the alphabet in each of the words that is formed. Okay, so you'll have to just fix one place.
Yes, so out of three word, we'll fix I,
Okay.
and we left with two places.
Uh,
There are five letters, right? So I is
there.
already taken. So the 4 factorial into 3 factorial.
No, I don't think so. That should be done. See, so first of all, Ujjain J is getting repetition. Without repetition, you have to use, right. You can't be using two. So if you're saying that 5P4, this is what you're saying, right? If this is 5P4, that means you'll be using J in some of the words. You'll be using the J as something like that, right? That should not occur because you'll have to use the like the word should not get repeated whenever you're forming that three word.
No, what I'm saying, like the three letter word, right? So I is already fixed.
Okay,
So there are two places are left. So
correct.
the the second place can be filled in one, 3 factorial ways.
Three factorial.
How
Okay,
many?
what?
One, two,
We
three,
can
four,
do some
five. Four
So the
factorial ways.
suppose
Four factorials.
I will fixed J and J we can't take in one shot. So J
J and J you can't.
fix. Yeah, J
You
we
have to
fix. In some cases,
separate case.
yeah,
Yeah, you have to
separate
make some separate cases. You have to
fix.
make.
Yes.
So one case you can just make it like that. The first case can be, what can be the first case? If J is not used at all, you are just using the remaining word. So you are left with UAAN.
Okay.
Only
Okay.
this three word you are using. Okay.
Yeah. Yeah. Okay.
So that can be the first case. The second case can be J is used only once to form the three letter. So then you are left with what?
The first case, how it will be then? Because the letter starts with from I, so UAN we can't take it, right?
No, no, it's not starts with. It's I should be one of the letters. I'm just saying I can be one of. So if you are using this three word later, I can be here also, I can be here also, I can be here also. In the remaining
So,
places, if you are fixing, so I can be at how many? Like if you have to arrange I, it can be at 1, 2, 3 ways, right? 3P1 base
Three.
that you can place I,
Okay.
So
correct?
three into
And
two
in,
ways, right?
no, no, and then you are left with three places, okay? And out of these three places, you can just place two words, right? Are you not-
So one place is taken by I. There are remaining two places. We have three letter in our hand. U A
are
N.
you-
Correct.
Correct,
So the second place can be filled with any one of this letter.
correct.
So it means what? Three ways we can fill the second place.
Yeah,
And and third place we can fill in two different ways because we left with two letters now.
yeah, correct. So 3 into 2, correct?
Yeah, yeah,
So 6 ways you are saying,
yeah.
but you can place I here also, here also, here also. So let's for example, you have just placed I here, and then 3 into 2 are saying, correct? So
Okay.
3 into 2, 6 ways. But you can place I here also, right? That will be a different arrangement. So you can put
Uh,
I here
three.
also. You can put so you have to multiply with 3, correct? So 18
Yeah,
ways is the correct. From the first case, this is just the one case. The second case is you have not used J at all. You have to use J also, correct? In the second case, you can use J. J in the first case we were not using because if you use J, there will be a repetition. So that's why you just remove all the J. 2J we have removed and then we have used UAN directly, UAN only. Right? The second case only. Second case can be where you are using J also. What can be that case?
So is it like 4P2? Can you
What?
consider 4P2?
24 ways.
4P2. 4P2? Okay. How did you get this?
Like we have four options left, or when we remove I, and then there are two places where it can be adjusted.
sir, we can actually do three cases where we fix position of I in the first place and position of I in the second place and position of I in the third place. And
Correct.
all these three cases will have 4P2 combinations, sorry, commutations. So what we can do is 3 multiplied by 4P2 will give the different letters.
Mm,
J will repeat. That one you need to remove, right?
what if you're saying 4P2? How are you saying? How you are saying?
So we
So
have
like
4
We have left with four.
U, A, N, and J. We have 4 different alphabets
No.
left to make a 3 letter word.
And what you are doing
Or
with the other J? Other J?
sir, we are not taking the we have lecture. We just have to use one J, no. So we don't allow repetition. We can just simply use one J because second J is also the same one. We are not taking that in consideration.
Okay. Okay.
So we are saying we have I in the first place, and there are 2 places left, and the alphabets left are U, A, N, and J. So we have 4 alphabets left. We need to fill 2 spaces. So 4P2, and then we change the position of I to the second place, again 4P2, and then we change the position of I to the third place, again 4P2. So we have just like this 3 multiplied by 4P2 number of 3 letter words.
Yeah. Correct. So 4 factorial is, I guess, some. Let's make all the cases itself. So see, in the first case, see, from according to you, you said 4P2 equals to 12 into 3, right? This is what you said, 36 ways altogether should be there. This is what you said?
Yes, Yes, sir.
Okay. So from okay, let's solve it. So from first case we are getting some 18 ways, right? We have
Sir, we can do this way, sir. I first
correct.
place suppose we need to fix. So total five letter words still present. So out of five, we need to select the two, and J is repeated two times. So 5C2 divided by 2 factorial. That we can do it, right?
Yeah. So in the second case, yeah, got it. In the second case, what? So in the first case we haven't used J. In the second case we are using J. So if J is used once to form three-letter word, yeah. So from this case also we'll be getting 18, I guess. So I guess yeah, 18 plus 18, 36 case should be weight should be there, I guess. Is this clear? 18, how it came 18 and 18?
No.
What? No or yes? So, see, in the second case, what you can do is I can be placed. I can be placed at three, like three P1 is like three, and then you're left with what? I am including J also, and then you have U, A, N. Out of this three, I can take one and then arrange it. So again three, and then J is there. J. Okay. Are we missing something or what? Okay. Let's try to. Yes. So we have to. The question clearly says that how many three-letters word with or without meaning can be formed using the letters of the word Ujjain without repetition. Okay, if there is no repetition, such that the alphabet is one of I is one of the alphabet in each of the word that is formed. Okay.
So sir, first place suppose it is I. First place we have taken. Then rest letters are five. So five letters. We can arrange it 5P2 divided by 2 factorial. One case.
Yeah. Correct. So
Then second is like this. I is coming to that way also. So 3 into 5P2 divided by 2 factorial.
4 into 3, and then I can be anywhere. So into three. So this should be the case, I guess. The 36 weight should be the answer. I guess, see, if you have Ujjain, right, and I can come in at any places, so can come at any places. And then out of these four words, I guess this should be the correct answer. So whatever he said, I guess that is correct. I guess this is correct, I guess.
What sir? In that case, suppose four words instead of with an UJIN. If it is there also, the answer is same. Then I think it is.
What can you repeat that? Can you repeat that?
Yeah, suppose UJAIN instead of UJJAIN will be there. Then also the answer is same. Then I think it is not correct. Sir. Instead of suppose J will not there. That is the instead of 2J, 1J will be there also. It is the same answer, right? So there is no difference in between UJAIN and U double JIN.
Sir, I have one more thing to say.
Yeah, go ahead.
Uh, we can consider three cases. That is fine when I is at the first place, I at the second place, and I at the third place. What we can do for the remaining two places is we can do 5p2 and we'll divide by 2 factorial because j is repeating.
That's
This
the
is the
Okay.
concept we had in rearranging letters.
actually, sir,
Yeah,
the
you can
answer
use.
will be
Yes.
3 into 5p2 divided by 2 factorial, sir.
Yes, because sir, we have two j's. No, to this when we will use the second j also, so we just have to eliminate those cases where these two j's are switching places. We just have to eliminate those cases. So we will divide by 2 factorial, which was the concept in rearranging letters.
Yeah, yeah. That from there also. See, the given answer is 39.
Yes, that's what I'm saying. We are missing three cases. That cases comes from that second j. What I'm saying, sir, we just considered UJAN, okay? We got
Correct, sir.
36. We are
Correct, correct.
missing those. We are missing that when we have I, J, and J. Then we have I in second place, J, I, J, and we are missing the third letter, which is I, J, J. These three letters we are missing when we are not considering two J's.
No, but we don't have to consider 2j, right? Whenever you're forming three words, you can't consider 2j because clearly
Sir,
written that you can't be using repetition of the word.
repetition is repetition of the. We are not repeating the first J. We are using the second J. So what I'm saying is J, J, I. So this first J is the UJ and the second J. See, we have two J's, no? JJI, JIJ, and IJJ. We are missing these three words when we are not considering two J's.
Yeah,
These
yes.
three words are not considered in the 36 answers. So answer will be 39.
Correct, correct. You're correct, but I guess the question is not clearly written. That see, if you have been given something like that, that repetition of word is not allowed. That that means JJ you can't consider. Like, but whatever you have said is correct. So that's why the answer is given as uh, three they have taken. So the third case that they have taken is when you are considering both the J. So if you are considering both the J, then you have three more ways, right? You can put like in three ways JIJ and JJI and or in the reverse way.
Yes,
Correct?
sir.
So
Yes, sir.
there are three ways. There are three ways that you can consider more, and then we'll be reaching out to 39 ways.
Yes, sir.
Okay, but if it is mentioned something like repetition is not allowed, I hope according to me it should be 36, but okay, that's fine. The explanation that has been given by you is also correct. I hope
Yeah, what I
that's
think the repetition is the I'm not using the same J. I'm using the next one. That's why
correct,
I'm
correct,
not
correct,
repeating it.
correct, correct, correct. So yeah, yeah. So according to whatever you have said, it's totally correct. We are not repeating the same J. We are basically using the both the day. You can use the both the J in the same word.
Yes, sir.
Correct, correct.
That's available to me, so I have to use it.
Okay, okay. Got it, got it. Yeah. So yeah, this was a bit maybe in the question it was not clearly mentioned, but yeah, thanks for clarifying this. Then you can have a question something like the shopkeeper wants to buy. This is simple. He wants to arrange four dark chocolate, two milk chocolate, and then two white chocolate in a row. So this is simple. Just it has been given something like that. The question is you have some four uh, chocolate of C1, second chocolate of C2, and the third is of C3. So this is simple, right? Uh, two. And then you have been asked how many ways you can arrange the chocolate. So it's like 4 factorial upon, sorry, not 4 factorial. This is 8 factorial. 8 factorial upon 4 factorial to 2 into 2. So this the formula that we have mentioned in P1, P2, and P3 factorial. Okay, something like that. You can use it directly. Uh, okay. The next question is in the same problem. The next question is you have been C1 types of chocolate, C2 types, or you can say that this has been mentioned as dark chocolate, and the second is milk chocolate, and the third is white chocolate, something like that. And then the next problem is in how many ways can he arrange the chocolates if all the dark chocolates are to be placed together? Did you get the question? In how many ways can he arrange the chocolates in such that all the dark chocolates should be placed together? In how many ways you can do that?
We will consider this dark chocolate four together as a one unit.
Correct, correct. So you have to, yeah. So you can just take the whole dark chocolate as a one unit. So you'll be left with what? So you have to just fill in 5. So this is 2, this is 2, 2 to 4, and then you can just consider this as a 1. So you have 5 factorial ways, and then you divide it with what? You divide it with 2 upon 2, correct?
Yes, sir.
Correct? Anyone has any doubt in this? Okay. Now the question is, in how many ways he can arrange the chocolate if no two milk chocolate has to be placed together? So you have to, from the whole cases, from the 8 factorial upon 4 factorial into 2 factorial to 2 factorial, you have to exclude all those cases in which the two milk chocolates were placed together. So if the two milk chocolate has been placed together, what will you do? You just have to take out this 2 as a 1, like this 2 as a 1. So you are left with what? 7 factorial, 4 plus 2 plus 1, 7 factorial, upon what? Upon 4 factorial into 2 factorial. Correct? And then you have to subtract it from where? 4. Correct? This should be the answer. Is this clear to everyone? So the
Yes, sir.
question was, I'll just repeat it. So the first question that was pretty simple, that has been given as, you have been given 3 different type of chocolate. One was dark chocolate, and the second was milk chocolate, and then the third was some white chocolate was given. The first question was, you just have to make the all. You will have to count the all the arrangement. So how do you count it? This simple, 4 factorial upon 2. So this was 2 into 4 factorial into 2 to 8 factorial. This is the whole number of arrangement. You already know that if there is some similar or same thing, you'll just divide it with that factorial itself. The second case was, it has been given that you're just putting all the dark chocolate at it, like at one place. Like, okay. So then you just have to consider this whole dark chocolate as a 1, and then the 2 cases of this and 2 cases of this. Correct? So you are left with what? 5 factorial upon 2 factorial into 2 factorial. The third case was, it has been asked that in how many ways can you arrange the chocolates in such a way that no two chocolates are to be placed together. So you have to just exclude all those ways where the two milk chocolate was placed together. Okay. So if the two chocolate are placed together, then you're just putting this as a 1. So 5, you're left with what? 4 plus 1, 5 plus 2, 7. 7 factorial upon 2 factorial into 4 factorial. And then you have to subtract it from 4 factorial into 2 factorial into 2 factorial. This should be the answer. Clear to everyone?
Yes, sir.
Okay. Okay. So I'll just deal with the combination. Combination is like, see, permutation, you are just choosing out and then arranging. So that is like the ordering or the arrangement is very important. In the combination, you just have to choose out. So in the permutation and this combination, is P. So if you have been given A, B, C, okay, and if you have been given three letters, and out of these three letters, you have to take out through 2 letters at a time and then arrange it. Okay. So then how many ways are there? If you have to just take out 2 objects and then arrange it, how many ways you can do it?
3P2.
3P2, correct? And if you have been given all these 3 letters only, and then you have to just hold that, you have to just choose 2 objects from this. You don't have to arrange it. Then what is the number of ways you can choose 2 objects from there?
3C2.
3C2, that is fine. 3C2, that is, but can you tell me the number? Is AB, BC, CA. Any other combination that you can take out? Any other combination that you can take out?
BA.
But here, no. So BA, if you are considering BA, that means what you are just putting, like you are mentioning, like what did I say? In the combination, you don't have to think about the order. You just have to take out 2 words. That's it. In the permutation, you have to take out the orders. Okay, so that's why. So here, A, B, and B A is different for the permutation. In the permutation, arrangement is asked. Okay, so if you have been asked about the arrangement, then you have to use the formula of the permutation. If you have been asked just to choose out, use directly the combination. Okay, so that's why permutation. So whatever the formula of the permutation was, NPR, you divide it with R factorial, right? Then you reach out to NCR, correct? Because in the combination you don't worry about the arrangement. So I didn't say, so out of these three you have to take out two words, right? So what did it so you have just done, you're just left with three different combination of words that you can take out from this three letters, right? But in the permutation, you were having six different arrangement, right? You just choose out, first you have taken out two words, and then you have to arrange, because even you are taking out two objects A, B, you can arrange those words in a two ways, right? B and AB. So that's why your combination was having how many different arrangements? Six. And then whenever you are dividing with two, you are reaching out to combination. Correct. So that's why the formula for the combination is what? NCR. How can you write it? NCR. So whatever the formula for NPR was there, and then you divide it with R factorial. Correct.
Yes, sir.
Yeah.
Yes, sir.
So it will be N factorial upon N minus R times R factorial. Okay. So this is NCR. In the combination, you don't have to worry about the arrangement. So that's why you divide it with R factorial. Okay. So I guess this is clear,
Yeah.
right? Okay. Now a question has been given something like, so in the exam there, in the paper there were 12 questions were there, and there was two parts of that, part 1 and part 2. Part 1 was having 7 questions, part 2 was having 5 questions, and you have to calculate, a student has to attempt 8 questions in all. A student has to attempt 8 questions in all. Okay, and at least 3 from each part. You don't have to worry which question they are choosing. Okay, you just have to care about that many 8 questions they have to choose out. 8 questions they have to attempt. That's it. So arrangement, you don't have to worry which question they are arranging. Okay, they're just asking, a student has to attempt 8 questions in all, and at least 3 from each part. Then what can be the number of ways that a student can attempt the questions? How will you approach?
So we'll create case one, like,
Yeah, 3 cases will be there, correct?
yeah.
Yes, sir.
So 3 questions they have to attempt from each cases, like from each part, right? So let's, for example, from the first part they have attempted 3. So whatever is left, how many they can attempt from the second case?
Five.
5,
5 questions.
right? So 5C5 multiply with 7C3, correct?
Yeah.
Now the next part can be they're attempting 4 questions, right? So
Seven C
7C4 into
5C
5C4.
four,
What can be the next case? 7C5
5C3.
5C3. Because now they can't go like 3 they have to attempt, right? Is there any other cases? If he wants to attempt 3, so 3 they have attempted from here, so 5, 4 they have attempted, and 3 5 3 they have attempted. Any other case such that the summation will be 8 and 3 you can just take out from the other case? There's no combination, right? Is there any case that is left?
No.
No, sir.
No, right? Yeah, this. Okay, so this is the case. And okay, so let's deal with some more problem. So these
Sir,
are
why
verses.
Why we are multiplying 7C3 multiplied by 5C5?
Because we have to attempt eight
And
questions altogether, right?
3 and 5, 100.
Yeah, three you have attempted, then five you have attempted from the other part. So altogether you have to attempt five questions, right? Five questions you have to attempt, correct?
8.
See, if you have to attempt eight questions altogether, three you are attempting from part one. So how many you are choosing out from the seven questions? Three, right? 7C3.
3.
Why you are multiplying? So multiplying, what did I say? In the starting, if you have n1 ways and n2, n1, n2, and there is a and case. And why? Because altogether you have to attempt eight questions.
Yes, sir.
Yeah. So that's why you're doing the multiplication here, not the addition.
Oh,
Correct?
yes, sir. Thank you.
And why we are doing addition here? Because this is also another case. This is
Or
another case in which you can attempt the paper. This was the first case in which you can attempt the paper 3 plus 5. This is another way 4 plus 4. 4 you are attempting from the first and the 4 you are attempting from the part 2. So that's the another way. That's why you are doing the summation. Is this clear?
yes, sir.
Okay. Yeah, and regarding the cards, you at least you are aware of those cards, right? So how many total cards? I'm not going to solve any problem. I'm just asking you whether you are aware of those cards or not. That how many cards are all together? Because there can be questions from the cards. Okay, if you don't know the cards itself, then that will be very difficult for you to solve the problem. So you have 52 cards, correct?
Correct.
Yes, sir.
Yes.
And half of them are black and half of them are red. Half of them are red. In the black, you have what? You have heart and you have diamond. In the black, you have club and a spade. And each of them has how many
13.
cards? 13 cards, right? In that 13 cards, you have one A, and then you have 2 to 9. 2 to 9 or 10? I don't know. 2 to 10, I guess. Or
10.
9. 10,
10.
right?
2 to 10.
10. And then you have one joker, one king, and one queen. Okay? So altogether, you have 13 in each of the suits. Okay, so you have club, spade, heart, and diamond. So at least this much you should be knowing, and then they can ask you any problem from the card because this is expected that you should be knowing. Okay, so mostly the problem there can be some one or two questions from the cards itself, like what's the from the probability or maybe from the combination permutation also there can be some questions. I hope this is clear. Permutation and combination is clear. Like the
Yes, sir.
basic idea you are done. Okay, let's move to the probability. Just have a break for 2 minutes and then I'll start again. Okay, from the cards itself, I'm just asking one question. In how many ways you can just choose four cards from this 52 cards, 52 playing cards, such that all four cards that you are choosing are from the same suit. Can you please mute yourself? Have you understood the question? So we just talked about that, right? So there are four types of suits, right? One is club, spade, heart, and diamond. Each one is having 13 cards. So here the question is four cards you have to choose out from these 52 cards in such a way that all the four cards that you are choosing out should be of same suit. Okay, if you are choosing out, so all should be diamond, or all should be heart, or all should be club or spade. Okay, in how many ways you can do this?
4 into 13 C4.
4 into 13 C4, correct. Right? How did you do that?
I mean, we have 13 cards for
Correct.
every
So
color, so 13 C4, and that multiplied by 4, or let us say 4 C1.
4 C1. Any person is having any doubt in this? Okay, if I'm asking, if you have to choose out the same thing, you have to choose out four cards from the four cards from 52 cards in such a way that all the four cards are of same color. Then
Then that will be
2C.
26.
Two
yeah,
times four.
2
2C.
multiply with 26 C4, correct?
Yeah.
Yeah, I hope this is clear. I hope, yeah, this is clear to everyone. In the probability, so basic stuffs you are already aware of. What is sample space, outcome, what are the like axioms of probability, like the probability value can't be more than one, summation should be this union, intersection, mutual exclusive, or is disjoint set. All these things are clear, or do you want me to explain this? This is simple, right? Can we directly solve some problems? What do you want?
Can I ask one question other than the math problem?
Yeah, other than maths problem.
I mean, I just want to ask you that where can we is this session getting recorded, and where can we find it for the our record purpose?
Yeah, this is live stream on YouTube also. I'll just, you can just go to that stats. I guess this is stats. There is a MA100. Okay, I'll just 1 second. Uh, you have been shared the link, right? YouTube link you have not been shared, or what? You have not been shared.
No, actually, I have not got the YouTube link. I've got the material link and this live session link only.
Okay, okay. What you can do, you can just uh, maybe you can just ping me. I'll just mail put my mail ID there. You can just ping me there, and I'll let you know. Okay, the YouTube link.
Okay, in this message only.
Yeah, I'll just write it out. Okay. I hope then. Okay. So, do I have to discuss the basic stuffs regarding the probability? I hope you already know what is experiment, what is random experiment. I'm not discussing this sample space. So all the outcome experiment is all any process that produces some outcome. And if you have some uncertainty, then you can say that it's a random experiment. Then all the outcome that you're getting is sample space, and then event for which you have, there can be some event, right? Collection of basic outcomes, right? And then union of events you already are aware of. I guess you have already read about the Venn diagram and all. You just write it as E union F, correct? Let's for example, if there is some questions and you can have answer A, B, C, D. Event one is like guessing answer A. Event two is guessing answer B. So E1 intersection E2 can be is A guessing answer AB. Okay. Then you have an intersection. Intersection also you are already aware of. So these are all Venn diagram ka concept. I guess sure. I'm just giving one question, and then if you're able to do that, we'll move to the further concept. I guess, and then the concepts are complement, all those subset, complement. Okay, let me write the question. So can you solve this? P of C. This is a Venn diagram. You just have to use the concept of union intersection formula. You have to calculate. Can you just give me an idea how will you solve this? You don't have to use A union B union C the formula. You can directly take A union B as some D, and then you can try it out.
Probability of A union B union C minus probability of A union B minus probability of C.
Yeah. Uh, yeah, you can just take that. If you're just taking this as a D A union B, you're just taking as a D. Then the probability
Yes,
of
sir. So
D union C.
probability of
So this I'm writing. D union C will be what?
probability of D plus
D.
probability of C minus probability of D intersection C.
Correct. This is, I guess everybody knows that. So point 0.8 equals to, from here, if you'll convert, this is what? The probability of C, or if you want to write it in the full Probability of C is what? You can write it like this: probability of D complement intersection C plus probability of D intersection C. Correct? If you have to take out,
Probability of C is given point C. Need
yeah, this is given
probability
point.
of D. Yes, sir.
This formula you know, right? This you can write it for any case,
Yes, sir.
because if D can be anything, C is this one, right? D can be anything, right? So you're just taking what of you just have to write for whole C. If you have to write it for whole C, and this is D. Let's for example, this is D, and this is C. So some cases are D. So C intersection D, this case will be included. So here this case is included, and D complement is what? The whole other thing, D complement of C. So this case will also get included. So that's why P of C you can directly write it as any event, D complement of intersection C plus intersection C with D intersection if there is an overlap. So overlap will come even there is a no overlap also. One of them will become 0 and the other will become 1. Correct? Is it? Yeah. This formula is this formula clear to everyone? How we are writing this permutation of C equals to permutation of D complement intersection of C. So I just told you, right? I just drawn this Venn diagram. So I'll just repeating it. So if you have some event C and the other event is D, this is C and this is D. If you have to write the complete value of the C, how can you write? This area,
Plus D complement intersection C ka plus.
correct,
Yes,
this
sir.
area, right? The black area you can directly write it as what? C intersection D. Red area you can directly write it as this is D complement, right?
D
Where
complement
D is not there.
intersection with C.
Correct. D intersection with C. So this is what I have written. D intersection
Yes, sir.
C and D complement
Yes, sir.
intersection C. Correct. So if you know this, you can directly write it. You can directly solve this problem. So this is what has been asked of D complement intersection C has been asked. Correct. So this is what permutation of C minus permutation of D intersection C. Now what do you need? This is this you already have 0.3. This is what you need. Permutation of D intersection C. How will you calculate this D intersection C? Is this given? No, not given. Okay, from here
This
can you
from
calculate
here.
this? From here you can calculate, right? This is 0.3. What is permutation of A union B? 0.6. Correct? So if you are
Yes, sir.
calculating, what's the value you are getting? This will be getting as minus 0. What? X. So x equals to 0.9
Point
minus 0.8,
one.
0.1.
Point one.
Correct? So it is, so you're left with 0.2 as an answer. And this type of problem can come in the exam also. So this you should be knowing. This complement you should be knowing. Complement I already, so complement is what? 1 minus, so permutation of A complement, sorry, probability 1 minus probability of A. You already are aware complement is just that 1 minus of probability of having the event A.
So one doubt here.
Yeah, yeah. Go ahead.
Sir, there below you took probability of D as 0.6, but should we consider as 0.4 because we took that probability of A union B complement as this one, right? Because,
Where? Here.
for example, the second line probability, yeah, this one, if you see, you have taken 0.6, but they have given,
Probability of this is D, right?
yeah, no,
Is
because
it?
here you took probability of A union B complement as D, right?
No, no. I have taken A union B as A union B itself as D. So that's why I've written pro- probability of D complement intersection C. You can see, right?
Okay, okay,
Yeah.
got it. Yeah, this is fine.
Yeah. Any other doubt? Okay. If there is no doubt, let's move to the next part. Venn diagram. I hope this is clear. Okay. So, are you aware of this disjoint set? What do you mean by disjoint set? If two or more like if there are two events that is occurring, right? When do you say? See, with the Venn diagram, if I'll show you, that's for example, this is event E1 and this is E2. Two or more than two events are said to be disjoint if they have nothing in common, like no intersection between these two. Okay, then these two events you can directly say it as a disjoint event. Okay, so that means E1 intersection E2 is phi. Then you can directly say that there's a disjoint, or you can say that mutually exclusive. Also, you call for the disjoint set also you call it as mutually exclusive. Okay, it's clear? Is this clear?
Yes, sir.
De Morgan's law. So these are all the formula. Like these are all simple things. Uh, uh, if you have gone through the lecture, you must be knowing that. So after Venn diagram events and all, the next important concept is the, I guess, the conditional probability. This formula, I'll just write it out: union and intersection, because there are some questions that will be there in your exam for sure from the Venn diagram also. This formula also you should be knowing. De Morgan's law, you are already aware, or are you aware of this De Morgan's law?
Yes.
Yeah. The next concept is okay. So in the conditional probability, so till now, so probability, uh, so the basic probability, you can be asked regarding some of the very basic probability, but whenever you move to the conditional, there are some important concepts such as independent event. Okay, uh, so saying this conditional probability, we'll start with that. So in this conditional probability, what happens is you can be, you can have an event. You can be asked regarding a probability such that, so some of the event has affected the other. Like let's for example, I'm just dealing with one example. You can be like for example, you're just rolling two dice. Okay, and if you're rolling two dice, you can be asked a probability such that uh, whenever you were rolling a dice, in the first dice you got a, let's for example 4. You can have 6 outcomes, right? So first outcome you got 4, and then you have been asked to calculate the probability such that the summation is 10, something like that. So the event, the first occurrence that has been already done, that is affecting the probability of the second occurrence. Okay, so maybe we'll solve one or two problems. The formula is simple. If you have been asked regarding, so two events are there. F is a one event and E is the other event. So that means this, the equation means the probability such that you have to calculate the probability of the event E such that F has already occurred. Okay. And how do you write this probability of F? Probability of E intersection F. Okay. And here also from one concept I told you about, if let's for example the occurrence of F is not affecting the occurrence of E. Okay. Okay, that means the probability is the probability of the event E is not getting affected from the like the event F. Then you can directly write this event as what? Probability of E given F as probability of E also, right? If F is not affecting E, can you write this? What I was saying is two event has occurred, E and F. Okay, so if E the occurrence of F is not causing any, the probability of event E is not getting affected from the event F, right? So you can directly write this E given F as E for an independent event. Can you write this or not? Are you there? Can you hear me?
Yes, sir.
So yeah, can you write this or not? For an independent event, probability of E given F will be probability of E, right? Because the occurrence of F is not affecting the occurrence of E.
Yes, sir.
So you can write it directly, right? So that means for any independent event, you already can say that okay. So probability of E intersection F, whenever you are able to calculate this mathematically, probability of E into probability of F equals to probability of E intersection F, then you can say that this is a independent event. Okay. And what was the case for the disjoint set? For the disjoint, what did I say? The intersection will be what? Phi. Correct? There won't be any intersection. This is for the independent event, and for the disjoint, it was phi. Correct? Because there was nothing common in between. So this was the E event and this was F. Is this clear?
Yes, sir.
Yeah. So if I'm asking you, if this is the formula that you already have, probability of A given B is probability of A intersection B upon probability of B. If let's for example A1, A2, A3, all three are disjoint set, then if you have been asked to calculate probability of A1 union A2 union A3 given B, what should be the value? You already know probability of A1 union A2 union A3. If all the three sets are disjoint, then what is the value? You can write it like this.
Probability of A3.
Correct, because all these three events are disjoint, there is nothing common. If there is nothing common, then the intersection part will get 0, right? So you can directly write it as probability of A1 plus probability of A2 probability of A3, right? So for this case you can directly write it as probability of A1 given B plus probability of A2 given B plus probability of A3 given B. given B. You can write it as like this, right? For the disjoint set only.
Yes, sir.
Yeah. So okay. So the next, I guess this is the conditional probability. The symbol like okay. So let's solve one problem. So it has been given that there is two bag has been given. A, there is one bag or box. You can say A, and there is another box B. This A contains 7 red marbles and 6 blue marbles, and the B contains 5 red marble and 8 blue marble. It has been asked that a box out of this AB is chosen at random. Okay, at random that means like there is a equal probability of choosing A or B, and then the marble is or the marble is drawn at random from the chosen box. Okay, so if an box is chosen at random, and then the marble is drawn at random from the chosen box, then you have to calculate that probability such that the red ball. So the first that you have to calculate, I told you the probability of 1 by 2 and 1 by 2 for both the box. So there is no biasness in this. What you have to calculate is probability such that the red ball is drawn given that whenever the red ball is drawn given that box A is been chosen. You have to calculate the probability for this case first, and then the second case, the same thing. The blue ball is drawn given that box B is chosen. How will you solve this? So the question was a box has been chosen at random, okay, and then some marble has been drawn out. Okay, so what is the probability that the red ball is chosen, or the red marble, you can think of red marble is been drawn given that the box A is chosen. What will be the probability for the first case? How will you solve? Like how will you approach this problem? What do you have to calculate? Probability of red marble given what? The box is
A.
A. Correct? How will you solve this?
Probability of
Probability of choosing box A, that means into
No, leave that formula. Conditional probability का formula. You just think of what should be the value.
so 7
We
divided.
already
Well,
know that.
first we
So what
can
is the condition?
calculate probability of getting a red ball in A. If we just consider A, we have A, box A, and probability of getting a red ball is 7 upon 13.
7 upon 13, right? See,
Yeah.
the information for the conditional probability, the information is given, right? You have whenever you were choosing the randomly, you were choosing the first of all. The first thing is what you're choosing the box. Here it has been given that the box is red. The box is A, correct? So given that the box is A, what should be the probability that you're just taking out some red ball out of that? 7 by 13, correct?
Yeah.
Yes, sir, 7 by 13.
Yeah, because information has been already given. So if you have to calculate conditional, if you go and solve with the formula, maybe you'll get stuck. So it's simple, right? Directly you have to go to that box A, and in that box A you have to calculate the probabilities of what is the probability of getting a red ball. So 7 upon 13. Now
Yes,
for the
sir. We are
second case,
already given we have chosen box B. So we
correct,
will
correct.
have 5 upon which is 13.
Yeah. For the second case, it will be 5 upon 13. Correct?
Yes, sir.
Is this clear to everyone?
8 upon 13, right?
Yeah.
Blue ball.
Sorry,
8
8
upon
upon
13.
yeah, 8 upon 13 for the blue ball, blue marble. Okay, so the next question is, if a family has two children, you have to calculate what is the probability that both are girls, given that at least one of them is a girl. This you have to calculate. See, you can calculate with the basic approach, with the formula also. Okay, how will you solve with the formula? You have to just calculate all the probability of the event E. Just you can just think of E event as such that for the two children, at least one should be girls. You can calculate the probability for that case, and then you can directly calculate probability such that GG.
Probability
So
for two girls.
yeah, that also you can calculate, or you directly think in that way that whenever you have a case, it has been already given that one is girl already, right? So what can be the case? Girl
G
is
and
already
one
fixed.
can. Yes, sir.
B and G, correct? So out of
We
these
only
two
have
cases,
two cases.
out of these two cases, GG can be one, right?
Yes, sir.
Give me 1 second. I'll just switch off my motor is on. Yeah. Are there? Can you hear me? Are you able to hear me?
Yeah, yeah.
Okay. Yeah.
Yes, sir.
So if you have to solve this, how will you solve this? Can you give me an idea? How will you solve this?
So either we can go with all the cases where one girl, boy, boy, girl, and either we can do your way, which answer will be 1/2 directly. If we think at least one is girl, there are only two cases left, which is girl and boy and girl, girl. And probability that both of them are girl is 1/2.
Yeah, in that case, both the cases are correct. You can solve it in any of the cases. So if you will go with the basic approach, what should be the, so it will be something like probability of GG intersection of what? It can be GB or GZ. Correct? Now, if you will take the order also, if you take the order BZ, then you're left with three conditions. And the whole condition should be what? Probability of at least one of them would be called, would be ZB, DZ, and ZZ. Correct?
Yes.
So, see, any method you can approach with. either you just use the formula directly, like the formula that we have talked about, like the conditional probability formula, or you can directly use that at least one of them is girl. Then that means what is the whole sample that you have, whole sample for
Whole
a given
sample we
condition.
have boy, boy, girl, girl, boy, girl.
Correct. The whole, yeah. Like if you're talking about the head and tail, you can just think of as a head tail condition, boys and girl, right? Okay,
Yes, sir.
so the whole condition can be at least one of them is girl. You can just think of as girl, boy, boy, girl, and then girl, girl. So all together three conditions, and out of this three condition, our condition is ZZ, right? So 1/3 should be the correct answer. Okay, and if you are just thinking in this way, if you just thinking this probability of E given F way, okay, then that also, so the F, our F event is what, at least one of them should be girl, right? So this is our whole F, correct? And then you have to take out
Yes,
the
sir.
intersection. E event is what, GG is our event, E1 E, and F is what, GB BZ ZB. So the intersection is what, again 1, intersection is 1/4. So again you are left with what, probability of
1/3.
GZ, and the down should be probability of all these three cases. Correct, right? So this is what, this is 1/3, sorry, 1/4, and the down is 3/4. You should be getting 1/3 as a correct answer. Is this clear, everyone? Is this clear or not?
Yes, sir. Yes.
Yeah.
Yeah.
Yes, sir.
Okay. Then we'll move to the law of total probability. See, law of total probability we have already dealt. Like I was just talking about the complement thing, right? That is like almost same as this. So if you have been given a event, okay, and this event, let's for example, this is the whole event. This half part is B, and the other half part, or you can just think of as this is B1 event, this is B2 event, this you can just think of as B3 event, and this is B4 event. Okay, and you have to write the law of total probability for some event A. This is the A event. Okay, this is A. If you have to write it, the permutation of A, how will you write this? I told you one method, right? Here, whenever we were solving this complement for a case, I told you one method. How will you write for this case? If you have to write the total
Yes, sir.
probability of A, how will you write this? Can you write it like this? Probability of A. This area is what? This area is what? A intersection what? B1. This area is what? Probability of A intersection B2 plus probability of A intersection B3 and probability of A intersection B4. Can you write it like this? Is this correct or not?
Yes, sir. This is correct.
Okay. And how can you write this? We already know if this is given like this. Can you write it? So for A intersection B, you can write it like this. Probability of A equals to probability of A equals to, you can just replace this formula everywhere. A intersection B equals to probability of A given, for this case it is B1 multiplication with probability of B1 plus probability of A given B2
B2
into
multiply
probability
by
of
probability
B2.
of B2.
Correct. Probability of A given B3 into probability of B3 plus probability of A given B4. Similarly, it can be n times, right? So you can use this
Yes,
formula
sir.
if you have to calculate the probability of the total probability. Okay. So in the same case, so we were solving. So this formula you have to use it now. So the same case, we were solving one problem, right? There are two box A, and you have box B. Box A has 7 red marble and 6 blue marble. Box B has 5 red marble and then 8 blue marble. Now, if an box is chosen at random, so the question you should be just listen carefully. If a box is chosen randomly and then a marble is drawn from the random from the chosen box, then you have to just tell me the probability such that the chosen ball is red. See, the question is what? If a box is chosen at random, then drawn. Can you please mute yourself? Is drawn at random from chosen box. Then find the probability that this is a red ball. This is a red ball or red marble. So here you have to calculate what? Law of total probability for the red ball. Are
Yes,
you
sir.
getting me? Correct?
Yes,
So
sir.
this red ball, so I told you, right? So if you have to calculate the probability of A can come from where? B1, B2, B3, B4, right? All the 4 places A1 is coming. Correct? So here, if you have to calculate the probability of red ball, so red ball can come from box A and box B. Correct? So from both the
Probability of
boxes you have to
red.
calculate. Correct. So how will you calculate that? Probability
We
of
will
what? The red
add
ball.
both probability.
Correct. So probability of red can come from where? Box B1 times probability of B1 plus probability of this red ball can come from where? B2.
Box
Given?
B2 multiplied by probability of B2.
Correct. So this method you can use it, right? Or in simple way, if you just think of you don't know the conditional probability, you don't know law of this probability. If you have been given that, find the probability of getting a red ball. How can you get a red ball? First I went because I have to get the probability of first I'll choose what? First I'll choose box. Correct. If you have to, I have been given 2 boxes. I'll just put my hand in one of the 2 boxes, right? And putting the hand in one of the 2 boxes is what? What is the
1 by
probability?
2.
Half. Correct. So I just went to this box. So probability of getting half. I just went to box A, and then if I went to like box A, what is the probability of getting a red ball? 7
Which
by
is
13
7 by 13.
plus. If let's for example, I went to box B, because from box B also I can get red ball. So probability of going to box B is what? Half.
1 by 2 multiplied by 5,
5 by 13. Correct.
13.
This is the total probability, and this is what we have calculated from here also. Probability of getting B1 is what? Half. Probability of getting red ball in B1 is what? 7 by 13. Probability of getting B2 is what? Half. And probability of getting red ball in B2 is what? 5 by 13. Correct. This is what we have calculated.
Yes, sir.
So law of total probability is simple, right? You can calculate it.
Yes, sir.
Yeah. So the last concept is what? The Bayes theorem. So Bayes theorem is like, see, the same concept. Whatever we have calculated, the probability of the total probability that we have calculated, that will be putting in the conditional probability formula. So conditional probability was what? The conditional probability was, see, B given A. If you have to calculate it, you calculate it by which method? Probability of B intersection A by probability of A. The law of from the law of total probability, you can write the probability of A. How can you write it? Let's for example, A is coming from some 5 6 different event, right? So you can directly write it all the summation of all the event, right? Probability of what? A given, like whatever the number is, probability of Bn, whatever the event that is there. So basically, so in the denominator you can just write the from the law of total probability, correct? And then numerator part, probability of B given A, what can you write it here? You can directly calculate the probability of B given A, or you already know so many formulas right now. A given B, if you have, you can directly write it as what? Probability of A intersection B is probability of B. So you
Multiplied
can write it
probability.
B intersection, yeah, you can just replace this value. It will be what?
Probability of A given B multiplied by probability of B.
Correct. Probability of A given B times probability of B upon the summation of probability of A given Bn into probability of Bn. So this is base formula. So in the same problem, so is this clear? So, so from the base theorem, for sure you'll be getting some question, one or two questions from base theorem. From the law of total probability also you'll be getting some questions for sure. Okay, so these all formulas should be knowing. So see, for the conditional probability, if you don't know the formula also you'll be able to solve it. But for the base theorem, you should be knowing the formula. Okay, then only you'll be able to solve it, because you have to
Yes.
calculate the law of total probability. And then see, in the base theorem, what will be given? You'll be given probability of A given B. Okay, and then probability of B. All those cases will be given. You have to calculate probability of B given A. So you'll be given probability of A given B, but you'll have to calculate B given A. Okay, in those cases, if you have been given those cases, you'll have to use the base theorem for sure. Okay, without this, you can't solve the problem. I hope this is clear.
Yes, sir.
Okay, see, in the same problem, this box problem where A is having 7 red ball, 6 blue ball, and the box B having 5 red ball and 8 blue balls. Okay, if you have been asked such that find the probability, so the same condition, if a box is chosen at random and then the marble is drawn at random from the chosen box, you have to find that probability. Then find the probability that the box A is chosen given that the red ball is drawn. Okay, so till now what we were doing, we were given the condition like the box A is given, like in the box A you have to find the probability such that red ball has been taking out
Drawn.
the red ball. Okay, now for the given formula, like whatever the condition has been given to you, you will be asked find the probability such that box A is being chosen given that this is a red ball. Are you getting me? So the
Yes.
different formula you have to use. So here, what you have to use? You have to use a formula such that, see, probability of B1 given A. This is what you have to calculate. B1 is what? What do you have to calculate? See, A is what? Our
Z box.
even correct. So you'll have to calculate such that probability of B1. B1 means the red ball is being chosen. See, my pencil is okay. I'll just speak out. My pencil is down. So what I was saying is, so for the same problem where the problem was box A is containing 7 red ball, 6 blue ball, and the box B is containing 5 red ball and 8 blue balls. The question here is, if a box is been chosen at random and then marble is drawn at random from the chosen box, you have to calculate the probability such that find the probability that box A is been chosen given that the red ball is drawn. Okay, the condition is been shuffled now. Till now, the condition was very simple. You have been given that box A has been selected, and then you have to find the red ball, like probability of getting the red ball. Now the condition has been shuffled. Now it has been given that it has been given that the red ball has been drawn out, and now you have to find the probability such that it is coming from the ball box A. Is this clear? The question is clear or not?
Yes, sir.
Yeah. How will you solve that? Just use the base
We'll
theorem,
use the
right?
base theorem.
Correct. So for this base theorem, what is the law of total probability? The total probability would be what? Probability of getting what? Such that you can get a red ball from any of the boxes. I hope you are not able to understand. See, for if you have been you have to calculate probability such that probability that box A has been chosen such that the red ball is been drawn. Okay, so the given condition is what? The red ball has been drawn. So the event that is given is what? The red ball. So probability of event A is what? The red ball has been drawn. So if you have to calculate, because if you have to calculate the law of total probability for probability of A, that means you have to calculate the law of total probability. You have to calculate such that how can you get, what are the probabilities such that you are getting a red ball from box A or box B, right?
So
This is law of
first
total
we
probability
will
for probability of A.
calculate the total probability of getting a red ball
Correct, correct,
through. Okay, then we also have to calculate probability red we have probability of B given A divided by probability of A. The probability of A will come from that red ball is drawn. What you said from total
correct,
probability.
correct. This is for the red ball, okay, and
Yes, sir.
then
This
you'll
is
be
for the
having
red
A
ball.
given.
We will have A given B1 multiplied by B1. Yes, sir.
Yeah, this event is what? Probability of choosing box A, okay.
Yes, sir. Probability of
Yeah,
choosing box.
yeah, so this is simple, right? So this you can calculate it directly, probability of the denominator part. Numerator part also it will be calculated. The second part is probability of B1 is what? Probability of given probability of getting box A, that is half, correct? And probability of A given B is what? Probability of getting
A
probability of
red
getting
ball
red ball from box.
in
Yeah, yeah, correct,
A. Yes, sir.
correct, correct. Probability of getting red ball from the box like A or whatever it has been given, and you can directly calculate the formula, like the you can directly calculate the final net. I guess the answer should be 7 by 12. You can just try it out. Okay. Is this clear?
Yes,
Is
sir.
this clear to everyone? Yeah. So this was the whole concept from week 5 to 8, like permutation, then combination, then the basic probability, and then you have the conditional and the base theorem. This is what from week 5 to 8 is there. In the final, for the final exam that is there on the 1st September, you should be knowing all these concepts. At least the basic idea should be having, solve some problems, maybe from the practice or graded assignment if you have been given the access for that. Or maybe the best thing is just get somehow the previous term paper, the final term paper for the stats one, and try it out, at least 2 papers. If you are able to solve it, then you are good to go. Okay. Any problem, any doubts you have?
No, sir. But final sem paper will is actually difficult way to get that paper.
Okay, you can just ping me on my mail ID. If I have something, I'll just share with. Okay.
Okay, sir.
Yeah. Anyone is having any other doubts? So I guess week 1 to 8 has been done. The last 4 weeks, and also the weightage for the last 4 weeks would be a, a bit more, like 40%, and then the remaining 1 to 8 will be 60%. Okay.
Yes, sir.
Okay. Anyone is having any doubt? Eh,
No, sir.
Yes.
So for any other confusion, any doubt, you can just ping me on my mail ID also. Okay, I just gave you the mail ID. Okay.
Sure.
Yeah.
Sure, sir.
Okay. Okay. So thanks all for joining the session, and all the best for your exam.
Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you.
Thank you.